We'll proceed in vector summation integral term. Okay, so we have waged a war with the vector summation and integral calculus. Vector is little something that is different. Otherwise, the inherent nature of integration is summation and multiplication and integral calculus. This is what we have been talking. How integral calculus came into the picture because of the summation only, because of the multiplication. If someone is multiplying two items, if someone is multiplying two items, let them settle it down while drawing a graph. This is called integral calculus. Doing multiplication by drawing a graph and computing the area is called integral calculus. Integral calculus is multiplying two items. That's it. That's it. Multiplication of any two item is integration. That's it. But integration is fx dx. Actually, it is fx into x. D is placed there to show it has to be the multiplication between fx and x has to be calculated through graphical way, not directly. That is fx into dx. If I say fx into x, then it is multiplication. Simple one. Fx into x is simple multiplication. Sin x into x, sin x into x is x sin x. This is simple multiplication. Whereas sin x into x through graphical way is integral calculus. Then what is difference between simple multiplication and calculating the multiplication through graphical way? Because both are different. If I say x sin x into x, that is x sin x, here both are independent to each other. Sin x is different thing, sin x is different thing, and x is different thing, and they are multiplying with each other. This is called multiplication. If we talk about sin x into x through graphical way, okay, if we talk about sin x into graphical way, then this is x-axis and this is sine axis. This is sine axis. Hop, hop, hop. If this is sine axis, then this is x-axis, this is sinusoidal axis. This portion what we are seeing is the area between x-axis and the graph. This is the graph. This is the dx fx, that is sin x is the graph, and this is x-axis. This is x-axis. This is sin x, that is the graph. In between, this is the area. This is the area. If I'm talking about calculating this area through graphical way, then this is x and this is sin x. If I do sin x into x, okay, what do you mean by graphical area? If I say 4 into 2, 4 into 2, where 4 is vertical and 2 is horizontal, 2 and 4, if I multiply, it is same as 4 is vertical and 2 is horizontal, and that is the area, 4 into 2. Similarly, if I say sin x into x, then this 4 into x, this is 4 and this is anything x, then this x into 4 is 4x. Okay, sin x into x, if this is the sin x, if this is the if this is the sin x, then this is x. Sin x into x, the way it was 4 into x was the area. Similarly, if this is the sin x and this is x, then sin x into x is this area. Makes sense? Where sin x, that is the vertical, it is varying. At every x, vertical is different. Okay, that's why I cannot say sin x into x is x into sin x. Sin x into x, that is the area. That is not the x into sin x. Means sin area, I cannot directly multiply anyway. Sin x will be different at different point of x. And okay, so what is the area of sin? Then someone will say, what you want? I want sin x into x from x is 0 to pi. This is pi and this is 0. Tell me this area. Okay, sin x into x is x sin x equal to pi. and sin x pi is 0. Area is 0. That is not, not true. That is not true. Okay, because x is pi and sine pi is 0. That is 0. Area is not 0. Means if I just say that multiplication of sin x into x is x sin x, that is all right. But if I say that multiplication is area, what do you mean by area? Sin x is a function over x. Sin x varies with x. Now tell me the multiplication. Means multiplication means are you trying to get the area? Yeah, multiplication means area one. That is the one way. There are two way multiplication are calculated. One by addition. If I say 5 into x, then 5 plus 5 plus 5 plus 5x time. That is also a way where multiplication is achieved. Or another way to achieve the multiplication is draw the area. 5 into x, vertical 5 horizontal x, and then get the rectangular area, get the area. That is also a way to calculate the multiplication. Or 5 plus 5 plus 5x time. Many ways can multiplication can be calculated. If we take area way, then calculation of multiplication through area way is integral. Then calculation of multiplication through repeated summation is not integral. Then calculation of multiplication through any other mean is not integral. Then if I want to calculate multiplication of items, and if I draw area, draw two item, one item is vertical and one item is horizontal, and I see in area in between and calculate the area, that is also a way to calculate the multiplication. That is integral calculus. So sin x into x, to differentiate it from normal multiplication, we write sin x into dx, so that people will be forced to draw a graph. If I say sin x into x, the person is forced to draw a graph now, because it is integral. It is calculation of multiplication between sin x and x by graph or by integral calculus. Then this will be this area. What we see, this area. This area is sin x into dx. This area. Okay, this area someone can compute. This is integral calculus. So one way is multiplication through area way is integral calculus. Multiplication through repeated summation is also possible. Or we can say repeated summation to multiplication, it is one way. Then multiplication to integral calculus. Vector summation and integral calculus. Okay. Now I believe we were in a very deep discussion to calculate dy by dt equal to cy equal plus s. dy by dt equal to cy plus s. This is a differential equation that we have in our hand. Dy by dt equal to c. C is a growth factor. Growth factor. It can be interest rate in bank, because that is a growth factor. So C into Y. Y is the current amount in the bank. If I take about the bank balance, then Y is the current amount in a bank account. C is the interest rate applied on it. C into Y is the net interest. Dy by dt is the change in Y per unit change in time. In bank, generally dt is per year. So interest that is accumulated per year, change in Y, change in the amount that is kept in the bank account, how much change in the amount we are seeing with the varying of the Y, that is delta Y by delta T over delta T period, how much change in Y we are seeing, that is delta Y by delta T. Per delta T, delta Y we are seeing. So per delta T, delta Y is the interest that we are seeing. If delta T is 1, then if delta T is 1, then delta Y we are seeing is the interest, or delta Y by delta T is the interest that is accumulated per year. Dy by dt means how much change we see in Y when there is a change in denominator as 1. That is dy by dt. Okay, means interest that is accumulated over 1 year over a principal amount of Y is dy by dt, and it is C, that is the interest rate per year, into the Y, that is the principal amount deposited. Okay, there is another fundamental of S. S is the external source. Externally, someone is depositing money in my account every year. Okay, this is what the concept generally people understand as far as dy by dt equal to cy plus s is concerned. Okay, we have done lot of way to calculate this differential equation. One way, what way we have seen is we took at two different sources. What we are saying, dy by dt equal to cy plus s. Per year, how much interest we are seeing in the account, that account interest is C into Y. At the beginning of year, how much was the money in the account? If I say year is the 0th year at the beginning only, then how much I have deposited in it into the account? That money will start growing as per the interest. And this is one source. There are two sources in my account. One source is the beginning money that I had deposited in the account. I opened a fixed deposit in bank, fixed deposit, and under fixed deposit, I have deposited one money in my account, and every year when I am seeing money is grown only because of the interest. This is called source. What is the source of the money? There is only one time source that I deposited amount in the begin of the year. This is one source. Okay, that is called Y0. There is another source that someone third party. Third party means a well-wisher. Third party means well-wisher. A well-wisher, he is depositing S amount. He is depositing S amount in my bank account every year. This is called S is third party deposition. Third party deposition means if I have dy by dt equal to cy, y is the amount that I have deposited in the fixed deposit in the first one go only, and after that there is one well wisher that he is depositing s amount of money every year in the fixed deposit. Every first year means in the 0th year S amount, first year after first year S amount, after second year S amount. Okay, then what is the Y at any moment? That is under discussion. What is the Y? What is the amount at any moment? If I say S is not there, I had deposited Y zero amount, Y amount at the beginning in the bank, then any moment what is the deposition in the amount, what is the balance in the account that I can expect any moment. Then we calculated this differential equation dy by dt equal to cy as y equal to y0 into e to the power ct. Y equal to y0 into e to the power ct means if I have deposited y0 amount in the bank account where it is a fixed deposit and it is growing at c percent, that is 5%, 5% per year accumulated means every time the principal amount will change as per the interest, but interest rate is 5% per year. In that fashion, any amount at any time, that is y equal to y0, that is the initial amount, e to the power ct, means if I have any amount in the bank, that amount will start growing at the rate of that amount multiplied by e to the power ct, e to the power ct. By that amount it will start growing. If I have deposited $100 in the account, 100 rupees in the account, 100 ruble in the account, 100 yuan in the account, 100 pound in the account, if we have deposited like that, then it will start growing. How? If y0, that is the initial amount I have deposited in the account, that is y0, that is $100. Then $100, 100 into e to the power ct. C is the interest rate. C is the interest rate. So 100 into e to the power c, that is 5%. 0.05 into t. At what time I want to see the current account. If I have deposited $100 in the account at the beginning, any moment what is the amount I can see in the account when amount get multiplied with the interest, that is y equal to y0, that is beginning $100, e to the power ct. T I have to place as year. Okay, means any money I deposit, it will start growing with the formula y0, that is the money I have deposited, e to the power ct. Okay, we are in the same formula, dy by dt, equal to ct plus s, cy plus s. Cy is the interest that is accumulated because I had deposited y0 money in the account, and s is the interest. Dy by dt is interest, then c into y is the interest, then plus s. S is also considered as interest only, though it is dollar per year, means every year someone is depositing s amount in the fixed deposit externally, external source. Or like if I have a inductor and resistor circuit, LR circuit, then S is the battery source outside. Okay, from externally, what is the power that is pushed into the circuit? Externally, how much someone is depositing every year in my account, that is called S. Dy by dt equal to cy plus s. If we see here, there are two sources of money in the account. One source of money that I deposited in the account as y0, so that will start growing like y0 e to the power ct. That is the one way. Another way is external person, he is depositing S dollar amount every year in the account. So there are two sources that account is receiving money. One source is that I had deposited Y0 amount in the account at the beginning only. And another source is S dollar someone is depositing every year in the account. Now tell me at any moment what is the Y, what is the money in the account Y equal to. Because of the source I had deposited y0, because of it, anytime money will be y0 into e to the power ct. But what about the money someone has deposited through the s? What about someone has deposited money through s? Okay, now we have calculated it. How we calculated? Then we saw two different sources of the money. We saw two different sources of the money. One source is Y0. Because of Y0, money will start. So I have a page, and there on top I have written Y0. This is the source of money. And money was placed in the account at the time equal to 0. Every year or every moment, the money will be Y equal to Y0 e to the power ct. I have another page for the first year, and there someone else deposited money S amount in the account. Thus, S will also grow like S into e to the power ct. Whatever you push, as per the time growth, that S amount will start growing like S into e to the power ct. So that S amount will, that is deposited in the first year itself, now that will also grow like ES into e to the power ct. Make sense? No, no. He did not deposit in the beginning of the year. He deposited after a time capital T. Before 1 year, that is true, but after a time capital T, then it will be S into e to the power C and in bracket T. T is a small t that talks about any moment what will be the money. T minus capital T, because he deposited after some quarter year or something like that. Up to him when he is depositing money. Understandable, right? If I have a fixed deposit account at t equal to 0, small t, there are two t I am taking into the picture. Or I can take small, there are two t, one is small t and one is capital T. The small t is the time that any moment I'll see what is there in my account. So at the time equal to 0, I deposited y0 money in the account. Any time that money that is y in the account will be y equal to y0 e to the power c into a small t. And then during the first year, someone deposited S dollar into my account after capital T from the beginning. After capital T from the beginning. Capital T year, that can be quarter year or it can be zero point 0.5 year, whatsoever. That S will start growing with the e to the power c and a small t. But since he deposited after capital T year, then it will be S into e to the power c and in bracket a small t minus capital T. Because if I take t from 0 to any time t, at the 0, y0 money was deposited by me. And after capital T time, S money was deposited by someone else. So for S money, this will be the time that it will be get interest, whereas my money will get interest from the beginning only. Y, and this is the small t time, y0 e to the power c into small t, and someone deposited externally at time s, at s money after capital T, then this duration is small t minus capital T. The s money will become s into e to the power c in bracket small t minus capital T. This is the first year someone deposited S amount. But I can take two balance now. One balance is how much Y0 will become any moment T. And another is how much S will become any moment T. Now S has separate accounts again. S deposited in the first year, S deposited in the second year, S deposited in the third year, S deposited in the fourth year. Now they have separate growth rate. First will grow for the t year more or less. Second will grow for the t minus 1 year because it was deposited after 1 year. Third will grow for small t minus 2 year because it was deposited after 2 years, something like that. So we have two source through which the two money, two money input into the my account. First money that I deposited at small t equal to 0, and second money is being deposited every year. First deposition will become what? First deposition will grow with e to the power ct. Second deposition will grow with e to the power ct. Third deposition will grow with the e to the power ct. Okay, instead of e to the power c and small t, it will be e to the power c small t minus capital T. It depends upon from beginning how much t has been spent. Makes sense? First S, first S is deposited at the end of 9 months. Then it will be S into e to the power c small t minus capital T will be 3 by 4, 3 by capital T will be 3 by 4, 3 by 4 of the year. Okay, second S is deposited after 1 year and half month. Then it will be S into e to the power C, and in bracket T minus 1, 1.5. After 1.5 year, that money was deposited, so it will get time to get interest, that if I say 0 to small t, then minus 1.5 year, this much time, it will not get the interest. This way we have to do. Then we saw that not two ledger balances there. One ledger balance Y0 is becoming up. In second ledger balance, S is going up. Okay, but S are deposited at various times. But each S we can write as S into e to the power c in bracket small t, that is fixed. I'll draw after a fixed small t minus capital T. Capital T is varying for each S. That I can say capital T. Then it is same for all S, means I have so many S. If I am seeing a small t as 20 years, then I have 20 S deposited. If I say that small t is 1 year, then 1 S has been deposited. Small t is 3 years, then first year, second year, and third year, 3 S was deposited. Each S will grow like S into e to the power c and bracket small t minus capital T, where capital T is the time from the beginning, how much time we delayed, that will become minus, because small t minus capital T will be this duration where S was deposited. Now for the S, I can write as S. Okay, there are many S. There is only one Y0, but there are many S. There are many S. How many S are there? Small t number of S are there. If I am thinking that I am going to check what is the amount I have in my fixed deposit after 15 years, then 15 times some external body has deposited SS amount 15 times in the 0th year, in the first year, in the second year, in the 14th year, or in the first year, second year, or 15th year, whatever someone understand better. Some external person, some well wisher to me, He has deposited this much amount in my money 15 times in 15 years. Means 15, there are 15 pages will be there as far as S is concerned. If he is depositing every 6 months, after first deposition he made after 6 months, next deposition he made after 1 year 6 months, next deposition of S amount he made after 2 years 6 months, last deposition he made after 14 years 6 months. At the end of 15 year, I want how much money it is. From my y0, it is y0 into e to the power c into 15, because every money will start growing into e to the power ct. First s will grow and s, capital S into, or small s into e to the power c in bracket t minus capital T. Capital T is the time lagging from the beginning, how much time he took to push the S money. Second S will become, after 15 years, second S will become S into e to the power c in bracket of small t, that is 15 years, minus what is the duration it took from the beginning, 1.5 year, 1.5. Third S will grow like S into e to the power c, and in bracket of small t minus 2.5. Small t is 15 years, 15 minus 2.5, only that period it will grow. Now I have 15s, but all s, if I write in abstract manner, then every s will grow like s into e to the power c, and in bracket a small t minus capital T, where capital T is variable. But I can say every s after t year, t means a small t year, from the beginning. From the beginning, if I take 15 years, then s is deposited meanwhile. Okay, every s, the amount I can see at the end of a small t, that is 15 years, will become s into e to the power c in bracket a small t minus capital T, where capital T is different for different s. But this is how we will write. If it is 15 times, then I can write I have money. The net money in the bank account is y0 e to the power c into 15 plus s into e to the power c, and in bracket 15 minus capital T into 15, because this is the one for 1s, the amount will become after 15 years minus whatever the capital T is s into e to the power c, t minus capital T. Okay, if it is 15 in number, then multiply, I'm sorry, if it is how many in number? Okay, if capital T is variable, how many times you are depositing? I am depositing capital T times. Capital T times. Since capital T is variable, I am depositing capital T times. Okay, someone will say you are depositing small t times. Okay, if I take in variable, then capital T times. Then I can leave the first part, that is constant, y0 e to the power ct. This part is s into e to the power c in bracket t small t minus capital T into capital T times into d capital T times, because it is independent component. Now I have to integrate this into capital T time, means I am taking, if it is deposited in capital T is in years. Okay, how many years it is deposited? Consider the person is depositing, external person is depositing a kind of every year. If he is depositing every year, I can rewrite as small s e to the power c in small t minus t1. T1 is the first year, minus t2, minus t3, minus t4 for any t, then it will be e to the power s into e to the power c in bracket a small t minus any t, means any cap t1 t2 t3. If I add all, s e to the power c and in bracket t minus t1 plus s into e to the power c in bracket t minus t2, t is small and t2 is capital, plus s e to the power c small t minus t3 plus e s small s e to the power c in bracket a small t minus t up to the t time, t1 t2 t3 t4 up to the capital T time. then it can be rewritten as s into e to the power c t minus t1 t2 what we were adding, it will be altogether written as s e to the power c in bracket small t minus capital T multiplied by capital T. This is the abstract notation to add it. If I am adding anything capital T time, it is multiplication. It can be transformed into integral calculus as small d and capital T. The way we said sin x into x is sin x dx. Okay, s into e to the power c and in bracket a small t minus capital T into capital T is into d of capital T, where capital T varies from 0 to small t. If someone calculate that, then we got it as s by c in bracket e to the power c small t minus 1. This is the this S factor will result in this much Y at any moment because of the S amount someone is depositing everywhere year. Any moment a small t, what is the money I can see in the account? That is S by C in bracket e to the power C small t and then minus 1 bracket close. This is the amount someone can see. What is the amount someone can see in the account because of the y0 that I had deposited in the account, that is y0 into e to the power ct. So net amount any moment after a small t time period, a small t year, anyone can see in the account is y equal to y0 e to the power ct plus s by c in bracket e to the power ct minus 1, where every t is small only. This is the amount. So this is from two stream of money. One stream is y0 that will become y0 into e to the power ct. Another stream is s that is deposited every year. Because of that stream, the money at any time small t will be s by c in bracket e to the power ct small t minus 1. Please watch our previous video for the detailed proof of it. Okay, now we have two streams that is accumulating and making the net y, money at any amount. We are talking about velocity vector. Velocity vector. What is velocity vector? We are trying to calculate y amount any moment. Y amount any moment. If I say I if I see a person had started from a point and he is walking, a person had started from a point and he is walking. Then after time t, how much distance he has traveled? This is the question. From the origin point, consider he is walking along x-axis, along eastward direction. And then after time small t, what is the distance he has traveled? How to find it? Okay, then the one way to find it is that at any moment you have to see how much, what is the equation of his distance per, as a function of time. Consider that his distance as a function of time is t square. Means any moment he will be at a distance of t square at time t. After 1 hour, he will be at a distance of 1 kilometer. After 2 hours, he will be at a distance of 4 kilometers. After 3 hours, he will be at a distance of 9 kilometers. This is the one way. What is the distance function that at any moment he will be? That is the y. Y equal to y0 e to the power ct plus s by c in bracket e to the power ct minus 1. Minus 1 is not e to the power ct minus 1. S by c in bracket e to the power ct come down and then minus 1 and bracket close. This is the any time, that is the amount that is in the bank account. Anytime y. Anytime how much distance he has traveled. Someone can place this formula only. Keep changing t and you will get the new distance that from the origin he at that distance. Same thing from the origin, what is the amount that he has in the account. So we calculated in this fashion. Is there any other way to calculate the amount at any time? Is there any another way to calculate the distance at any time? Yeah. Tell me what is his speed? What is his speed? His speed is his. I'm sorry. His speed is t to the power 3. Hop. His speed. I'm sorry. His speed is t to the power 3. That his speed up. His speed is t. His speed is t. His speed is t. T means any moment what is his speed is. When time is zero, then speed is zero. He started from the rest. When time is 1 hour, his speed is 1 kilometer per hour. When time is 2 hours, his speed is 2 kilometer per hour. When time is 3 hours, his speed is 3 kilometer per hour. Now tell me after 3 hours what distance he has traveled. If I know velocity, if I integrate the velocity, I'll get the distance. That is another way called velocity vector. If I know the velocity vector, then I can calculate the distance he has traveled. Okay, this discussion is about partitioning problem into n different part summation integral. This is what we used earlier. Dividing our S into n different part and each part we tackled and bring it up to a summation. Summation was brought, summation was, so I reiterated, so summation was S e to the power C small t minus capital T1 plus S e to the power C small t minus capital T2. This is dividing problem into n different parts. Then you sum it, summation I equal to 1 to n. Okay, I equal to 1 to capital T whatsoever. S into e to the power C in bracket small t minus I. Okay, this is I. So I can replace with capital T and it will become a abstract mathematics, and then we can go for integral calculus. Anyway, we'll proceed now. If I have integral, if I have a velocity vector, if I integrate the velocity vector, I'll get the I'm sorry. If I integrate, this is time axis and this is velocity, it is t. T means this is the velocity graph. If I calculate the area from this line to the x-axis area, that will be the distance traveled. So velocity is t means t dt, t square by 2, any moment. Now what is the distance formula? T square by 2. If velocity is t, if velocity is 2t, then distance graph is t square by 2 into 2, t square. That is the distance at any time. So if I know velocity, then also I can calculate the distance. Anyway, now I want y. I want y. What is the amount in the account any moment? I want y. Okay, y equal to whatever I have. To have the y, can I have dy by dt? What do you mean? What is the interest? What is the velocity vector for the y? What is the interest vector? What is the interest formula? If I know the interest formula, if I integrate the interest means dy by dt. Interest means dy by dt. How much y as a principal amount is changing with the time? That is dy by dt. Interest is dy by dt. Okay, if I have two sources of income, two sources of placing money in the account, one source is I deposited at the beginning, that is y0, and another source is S amount that is being deposited by someone else every year. Two sources are there. What is velocity vector for these two? Means interest vector for these two. For first, the interest vector is C into Y. C into Y, that is the interest, into e to the power ct. Interest vector is Cy, and that is going with the time. Tell me the formula of the interest as per the time. If y is the money at any moment, y equal to y0 e to the power ct plus s by c in bracket e to the power ct minus 1. This is a distance formula. Distance at any time, money at any time. Tell me the velocity vector formula at any time. Velocity vector formula at any time. There are two sources now. One source is y0, so y0 will have separate velocity formula. S will have different separate velocity formula. Then I have to add these two velocity formula to get the actual distance or to get the actual amount. What is the velocity formula for the y0? It is c into y, that is the interest, into e to the power ct. Interest will start growing at the rate of e to the power ct. Anything will start growing e to the power ct. If I have an interest, that is the velocity vector. For the y0, then c into y0 is the interest amount. Y0 is the beginning amount, c is the interest rate per year. C into y is the interest, into e to the power ct is the velocity vector, because interest will start growing like that. What is the velocity vector for the another amount? Another velocity vector for the another account. S itself is the interest. If I see the first formula, dy by dt equal to cy plus s, c into y is the interest because dy by dt is interest. If I see the unit, s in itself is the interest because that is year by that is money by money per year. So S for the second source of the income, money that is placed in account, S is the interest. So S into e to the power ct. Now we have two velocity formula. One velocity formula is C into Y. C into Y e to the power ct. This is the one velocity formula, or C into Y0 rather. C into Y0 into e to the power ct for the Y0 account amount. For the S, where S itself is interest, so S into e to the power ct. Okay, means these are, if I integrate this velocity formula, means dy by dt equal to cy0 e to the power ct plus S into e to the power ct. Interest formula as per the time for the S and interest formula as per the time for the Y0. Let's add it and integrate it. I'll get the money at any time. If I integrate velocity vector, I'll get the money at any time. If I integrate c into y0 e to the power ct, then c will come out as 1 by c. It will become y0 into e to the power ct. Another will become s into e to the power ct. It will become s by c e to the power ct plus a constant because integration is there, plus a constant. This is the y. Y at any time is y equal to y0 e to the power ct or c into y0 by c e to the power ct plus s by c e to the power ct plus constant. This is the y. Let's settle down when t equal to 0. When t equal to 0, what is the scenario when t equal to 0? Okay, when t equal to 0, then y is y0 at that time. When t equal to 0, the money in the account is y0. Y0 equal to y0. Y0 equal to y0 plus s by c e to the power ct is 1 because t is 0. S by c plus k. K constant equal to minus s by c. This is not available in any of the book. This proof of dy by dt equal to cy plus s through velocity vector. This is the only we are talking about velocity vector. Now it becomes k equal to minus s by c. So now formula will be y equal to y0 e to the power ct plus s by c plus s by c, y equal to y0 e to the power ct plus s by c e to the power ct minus s by c. That will become s by c in bracket e to the power ct minus 1. Amazing, mind blowing. If we find velocity vector for the both the sources, if we integrate, we can get the net amount any moment by this formula also. Okay, please do not mind supporting us. Plus 91 is the India country code 9483160610 telephone number. Plus 91 is the India country code 9483160610 is the telephone number. Okay, we will proceed on much awaited Taylor series. Can we achieve Taylor series? Taylor series is a very famous series, or Maclaurin series. Fx equal to f0 plus dy by dx or dfx by dx into x plus d2fx by dx square into x square by factorial of 2 plus d3fx by dx cube into x power 3 by factorial of 3. Can we achieve this through velocity vector? Is it really possible? And then dividing into n different part and summation, and then by vector, everything together, can we bring it Taylor series? Is it really true? The Taylor series really works in real life? That we will see.